Okay, so the slope formula is used to find the slope when you don't have a graph. And so let's go ahead and talk about that. So we're going to learn how the slope formula works from this example. So it says to find the slope of the graph, Aiden chose the 2 points shown and counted the rise to be 2 and the run to be 6. Okay, so he wrote out the coordinates. Okay, I'm going to go ahead and point out the x and the y values. Okay, so I'm going to color code them. So I'm going to point out that the x numbers for each point are 3 and 9. Okay, so if you have some way of color coding, use one color to identify the x points. Okay, and then let's highlight the y coordinates. So we've got 5 and 7. Because we're going to notice something right now. So he figured out using the values in the ordered pairs, so not the graph, but just the values. He found that the rise was 2, and it is 2, right? You go up 2. But how can you use the numbers 7 and 5 to get 2? Subtract. So he subtracted the y values. Let's write that down. So he found that the rise to be 2 because he subtract y values. The rise has to do with the y coordinates. So he did 7 minus 5 equals 2. And if you notice, those are the two values I color coded in green. So I did the same thing for the run. Using the values in the ordered pairs, how else could Aiden have found that the run to be 6? So he used the x values. How do you use those values? We've got 9, we got 3. How does that give us 6? Subtract again. So this time he did 9 take away 3. And that gave him 6. Okay. And what did we color code those numbers? 9 and 3 are both orange. Okay. So I got those numbers, and if he got 2 and 6, how did he end up with 1/3 though? Because the answer ultimately was 1/3, right? 2/6. Yeah. Just at some point, not all the time, but every so often, you take the difference in the y values, which was 2, over the difference in the x values, which was 6, and you simplify the fraction. Divide by 2, you get 1/3. Okay? And that's how you get your final answer. We would have had to have done that anyways if we did rise over run. Right? Simplify the fraction. Well, basically, that's what the slope formula does. You subtract y values, get an answer. You subtract x values, get an answer. And then you set up the ratio, and then sometimes you have to simplify the fraction. Okay? So when we don't have a graph, that's how we're going to do that. All right. So let's go ahead and look at the actual formula. So I'm going to zoom in as much as I can for the people in the back so we can all see this carefully. There we go. I don't like that because it makes my hands look huge. Okay, so let's see here. The slope formula. So have you guys ever used this slope formula before? No? It's not that difficult to use. You just have to be careful when you have negatives, but that's the case when we have negatives all the time. All right, so first of all, there's a special variable we use when we're finding slope. And you would think that it'd be the letter S. S is the most common letter. It's S for slope. It's actually the letter M. And so the full formula usually has M equals, and then you got these Y values that you're subtracting. Anybody know how we would say this particular Y second? That would make sense, right? Because it's kind of like an exponent, but it's underneath. It's called the subscript. So it's not a power. It's not Y times Y. What it means, it's the second Y. So we call it Y2. So it's Y2 minus Y1. And this means the first Y. Okay. Same thing in the denominator. This is X2, the second X, minus X1, the first X. So all it's telling you is the order in which you subtract your X and Y values. It's not telling you anything about exponents or multiplying things. It's just telling you, take the second X, subtract it with the first X. Take the second Y, subtract away the first Y. That's all it's saying. Okay? And so what we're finding is basically what we did up here. Up here, we subtracted X's, we subtracted Y's. Over here, you're finding the difference in X, difference in Y. I'm going to write that down. Difference in Y, or in Y's, I should say. That's what you're doing in the numerator. Down here, you're finding the difference in X's. Okay. So we're going to do a little, kind of like a math experiment. We're going to find the slope. We're going to pick 2 points. It says use the formula to find the slope of the graphed line. So to use the formula, I need to find some values, some coordinates. So I'm going to pick some coordinates and find the slope. Okay. Let's see here. What shall I pick? Okay. I'll pick this one. And I'll pick this one. Any 2 points will do. So I think those would work. All right. Well, let's see. I need the coordinates, though. I need the actual numbers that go with the points. So let me find the coordinates for this one. What are the XY numbers for this point up here? 6. And then you look across it, 6 and 3. 6 for X, 3 for Y. That's 1 point. Let's do the same thing for the other point. Let's see, what do I want there? 9 and 1. Okay. So the first thing is to get some points. We got some points. They're on the line. The next thing is we have to assign them. X1, Y1, X2, Y2. So we want the first ordered pair and the second ordered pair. So this is my first XY. I'm going to call it X1 and Y1. Okay. This is the second one. I'm going to call it x2 and y2. Okay? And after a while, we won't need to do that. But the first few times, it's a good idea. And what I'm going to do is I'm going to color code these. Okay? So this time, I'm going to color code them by the first one and the second one. So these two ordered pairs, 6 and 3, that's my first ordered pair. I'm going to take one of my colors, in this case, this yellow, and I'll color it yellow there. I'm going to take the second ordered pair, 9, 1. I'm going to color it a different color, in this case, orange. Okay? And now I'm going to use the formula. This is the formula. I'm going to do my work for the formula over here. Okay? You guys ready? So over here, we're going to basically rewrite this formula, but I'm going to leave where the variables are blank. So I'm going to write this as m equals, and it's just some subtraction in a fraction. I'm going to leave the other parts blank. But look what I'm going to do. Well, I won't do it that way this first time. This first time, I'm just going to go by what the formula says. I want the y values in the numerator. I want to start with y2. Look how I labeled them. Which y2 is going to go right here. Which number is y2? 1. Do you see it's right there? There's y2 and it's 1. So I'm going to put the 1 there. Okay? Then I'm going to subtract away y1. Which number is y1? Which one is it? 3, right? It's right there. So 1 minus 3. Got that. I'm going to do the same thing with x's. I'm going to do x2 minus x1. So which number is x2? 9. So I'm going to put the 9 there. And then what number would go here? 6. x1. Now, I'm going to go back and color code these again, right? So I'm going to start with 1. 1 was orange. So I'm going to color that orange. And then I'm going to color the other one, y2, that was yellow. So I'm going to go back and color code them with those colors. What color was 9 originally? Orange. And that makes 6 yellow. Okay. Now, do you notice something with the way they're colored? You got orange on top of orange and yellow on top of yellow. Like a fraction. That's going to help us figure out how to put these numbers in there. So I'm a visual person, and maybe many of you are. This is how I do this. Whenever I have to use this formula, I know that numbers go on top of each other in the subtraction, right? And here's how I do it. I take the second ordered pair, this one, right, 9, 1, and I'm going to visualize that I rotate this way. Imagine you take the numbers and you can transform them so that one's on top of the other, 90 degrees counterclockwise, like this. If I do that to these numbers, which number would be on top? 1 would be on top and 9 would be on the bottom. They go right there. So you turn it, put it in there. Then I do the same thing to the numbers I subtract. I take them, rotate them 90 degrees. 3's on top, 6 is on the bottom, and they go right there. If you can remember to do that each and every time, you'll set up the problem correctly, so you don't have to worry about that. Any questions? So we'll practice that. Now let's do the subtraction. All right, so we're going to subtract. What are we subtracting? 1 take away 3. How much is that? 1 take away 3. Negative 2. And then we have 9 take away 6. 3. Okay. And I got negative 2/3. Now, can I reduce that? Nope, that's it. Is that the correct slope? Is that the actual slope for the line? Yeah, it is. Look. Down 2 over 3. It's negative 2/3. Okay, so there's two ways to do it. Obviously, since I had the graph, the quicker, better way in this case is rise over run. But in a pinch, if you don't have graph paper, if you don't have that, you got the slope formula. And sometimes we're going to have to use the slope formula. Those situations will be coming up. All right. So we're just going to practice finding the slope using this formula, okay? All right. So we're going to do the following. It says a graph line passes through each of the following pairs of points. Use the slope formula to find the slope of each line. Show all work. Okay, so let's do this. We're going to do letter A. So to begin with, we'll label these. I'm going to label these x1 and y1, x2 and y2. Okay, go ahead and write that down. Label them the first x and y, the second x and y. Okay, we'll start with that. And then I'm going to write the slope formula, just the formula part over here. And for that, I want y2 minus y1, x2 minus x1. Okay? Now, let's actually put in some numbers. So it always starts this way. And I kind of like that color coding method. So I'm going to continue with that. I'm going to color the first ordered pair in one color, this yellow. And I'm going to color the second ordered pair in that orange. And it's always the second ordered pair that gets stacked in the first position right here. So I'm going to color that orange. And the first ordered pair goes behind it. So I'm going to color that yellow. Right there. So let's put the numbers in. Let's see where they go. So here, the orange numbers are going to go one on top of the other here. Which number goes on top? 7. Again, you want to picture that you rotate them. 7 on top, 1 on the bottom, and they go over here. 7 on top, 1 on the bottom, they go there. Now we're going to go to the first ordered pair, the yellow ones. Which numbers go on the top and the bottom? What goes on top? 4. 4 on top and 2 on the bottom. Okay. And now we just have to do the subtraction. Let's see what that gives us. Well, here I'm going to write the answer over here. 7 take away 4 is 3. How about 1 minus 2? What's 1 minus 2? Well, 2 minus 1 would be 1. 1 take away 2 is negative 1. So we get 3 over negative 1. Or, if we simplify that, just negative 3. Okay. So the final slope is negative 3. Okay. Any questions? Okay, so let's practice this a few more times, and then we'll have an assignment with this. So let's try the next one. We're going to label them x1 and y1, x2 and y2. Okay, let's start with that. We'll write the formula one last time. y2 minus y1 over x2 minus x1. Okay, and let's see what we get. All right, so let's put in some numbers. I'll color code them again. I'll make this one yellow, this one orange, and this is going to be where the orange numbers go. And this is going to be where the yellow numbers go. Okay. All right. So let's see here. We want to put the numbers for this first position. Which number goes on top? Remember, you turn them and they go in. -5. -5 on top, +5 on the bottom. Okay? And then we're going to do the numbers in yellow. Which one goes on top? 3 or -1 or 3? 3. And then I'm going to, since this is negative, I'm going to put parentheses around it. Okay? So now look what I got. -5 minus 3. In the numerator, 5 minus -1 in the denominator. Anytime I see subtraction with negatives, I'm going to switch it to addition. Remember, keep, change, opposite? We're going to try that. So over here, I'm going to rewrite the problem as an addition problem. So instead of subtracting, it's going to be plus. Remembering that any subtraction problem can be rewritten as addition. So remember, it's keep, change the subtraction to adding, and then you want the opposite. So the -5, do I switch it or do I keep it? Does it switch to +5 or does it stay -5? Yeah, it stays negative. You keep it. The first number always, that's the keep part. Keep it -5. Whatever it originally was, it stays that way. The minus changes to plus. There it is. And then a way to think about what you do with the second number is you push that minus sign onto the number. So if I push this minus sign onto the 3, what does it become? -3. So there's my new problem. -5 minus 3 becomes -5 plus -3. Okay? Let's try that with this one. Obviously, what do I do with the 5? Keep it. Just leave it there. It stays +5. This minus sign goes on to the negative. What's minus and negative become? What's a negative negative? Positive. So the plus changes to plus, and this becomes +1, not -1. So this becomes 5 plus 1. Okay? And now just use integer addition. Same sign, add and keep. 5 plus 1 is 6. I get -8/6. Can I reduce that or do I leave it? Yeah, I can divide by 2, obviously. 2 goes into both of those, so let's just see. -8 divided by 2, -4. 6 divided by 2, 3. So that's the slope for this line, -4/3. And this is about as hard as they get. That's about as difficult as these get. If you were able to follow and if you can do all that, this isn't so bad. Okay? All right. So I want you to try the next one. I want you to try to set it up. So let's do this. I'm going to leave this way. We can color code it if you want. But I want you to put the numbers in the right position. Go ahead and try. I'll leave the rest up to you. Using the formula, locate the numbers in the right positions. So hopefully you got 22 on top, 10 on the bottom, 11 on top, 8 on the bottom. Now we just have to figure out what that is. Let's do the subtraction. What's our numerator going to be after I subtract? 11. And then the denominator is going to be 2. So 11 halves. Do I change that to 5.5? Remember what we said about improper fractions with slopes? You leave them that way. This is literally the answer. 11 halves. Think about what that would be if you're graphing. You would have to go 11 spaces up and 2 across. That's a very steep line. If you were building a ramp and its slope was 11 halves, that would be pretty dangerous or a lot of fun. Yeah. Okay, last one. Okay, you guys ready? Well, you're going to set it up by yourself. So same as the last one. We'll color code these. But I do want you to set it up. Put the numbers where they belong. Okay. So hopefully what you put down is 6 here, -1 there, 9 here, and -1 here. I'll put parentheses on this one. Okay. So I see negatives. What do we have to do, or what should we do? Keep change opposite. Change them to adding addition problems. Okay? So if I have 6 minus 9, what would that be as an addition problem? 6 plus, and then this minus sign, you push it onto the 9. So the minus goes onto the 9, negative. If I have -1 minus -1 minus -1, what is that as an addition problem? -1. And then how about this one? -1 plus +1. Again, you take the minus, push it onto the negative, you got a negative. That's a positive. So it becomes -1 plus +1. So let's see what that gives us. let's see here. I'm going to write the answer over here, obviously. So let's see. 6 plus negative 9. How much is that? Negative 3. Sounds good to me. How about negative 1 plus 1? 0. We got a 0 in the denominator. What does that mean? Well, if it was in the numerator, I would say it's... So, if I had this, if I had 0 over negative 3, that's going to be 0. But I have the reverse of that, right? I have negative 3 divided by 0. What is that going to be? We really don't divide by 0 that often. Here, let me do it the right way. Negative 3 divided by 0. This is what I want to figure out the answer to. Calculators are never wrong. Or are they? What's that? Error. Divide by 0, error. The thing is, mathematically, it's impossible to divide by 0. Because here's what you're saying. Give me a number and divide by 0. Let's say I want 5. I heard 5 divided by 0. Remember, the denominator, we want to know how many times the denominator divides or goes into the numerator. How many times will 0 go into 5? Will it? How much? If you have a box and you want to fill it up with nothing, how much nothing can you fill in a box? An infinite amount, right? But if it's negative, can you do an negative infinite amount? See? Dividing by 0 is messy. There is no possible way to do it. So you know what this means? Remember we had positive slope, negative slope. What else did we have? 0 slope, which this isn't. And what was the fourth choice? Undefined. This is undefined. So when you divide by 0, it's undefined. Notice what I said, divide by 0, the denominator 0. So basically, this is a vertical line. This is a line that goes straight up and down. Okay? All right. So in a little bit, I'll pass out the glue sticks so you can put this in your notes. But this is the assignment that we're going to be doing, is doing something like this. I just want to make sure, is anyone still writing this? Okay.